Hi everyone. So again, my name is Denis Magda. I'm a Vice President of Product Management at GridGain. And I have a pleasure today to co-present with Jeff Bean of Confluent.
Hi everyone, I'm Jeff. I'm a Partner Solutions Architect with Confluent. I'm working our business development team, and I'm responsible for validating and verifying partner integrations with Confluent Platform, including the GridGain connector.
And when we were trying to come up about, like, we have two different platforms and products. Kafka Confluent is used a lot for streaming, real-time streaming, processing, querying, etc. GridGain is used as your final data destination, like where the whole data that is passing through the pipelines gets into, and then after that you can do more advanced queries and searches. And the goal of this session would be a little bit practical. We will do a brief overview of how both technologies can be integrated in together. And after that, we will show you a template or a sample demo prepared for these use cases. And you can refer to it whenever you are going to build their Kafka streaming pipelines driven by Confluent. And when GridGain is used as your final destination, your final database storage that can keep all the data needed on disk and RAM, and you can run queries. While analytics, so why we want to talk about this component? Generally speaking, there are many APIs available from Confluent, from GridGain, etc. But for this presentation, we want to focus on SQL, pretty standard and universal language for querying, and all the data that you will see during the demo that will be pushed through the Kafka pipelines and topics, we are going to use SQL to query it in real time. At the same time, as soon as the data arrives to your GridGain cluster, then we can run more advanced, like the same queries, but over the larger data set. We already introduced ourselves so that you can distinguish. And digital transformation. So why this joint integration between the products makes sense? Nowadays, when we are talking about the modern workloads, we are dealing with several things. 10 times or hundreds times more queries need to be processed by our storages, by our systems, by our infrastructure. At the same time, all of those operations have to be executed over a much larger data set. And finally, it's not only about transactions. It's not only about OLTP or transactional workloads. Usually for those workloads, yes, we would have tough requirements, seconds, milliseconds, or microseconds. But as for the analytical guys, BI, etc., they also want things to be completed not overnight when they have the infrastructure available for complex batch operations, but also like during normal business hours when they would like to issue some query that would analyze customer demographics, refer the data to the payments, and they would produce some report that can be used by the business during the normal working hours to do some kind of actions. And the problem with this architecture is that there is nothing wrong with the applications. Applications are using the same technologies, and like Java, Spring Boot, Kafka, etc. But the place where the data is stored, or the place how the data is being streamed, needs to be revisited. Because classical, traditional databases, they're designed for vertical scalability, and that doesn't work well when you have to deal with ever-growing amount of data, like 50 times more data has to be processed these days. And when you're pushing, or when you want to analyze, look at your data in real time also, you need to select the proper framework. So, Jeff, why don't you tell us about the first component?
Sure, and then there's another issue, which is that, real-time query is great. You can have queries that come back quickly. If the data is in your repository already, if you have an in-memory data store that you can query very quickly. But then if your data is flowing through your business, if your events are flowing through your organization, how do you interact with that data? And can you interact with that data in a meaningful way? One of the things that we see with Apache Kafka is that it is adopted really nicely in an incremental fashion. Rather than doing something like this, where I have app number 1 connecting to database number 1 and line of business number 1, and that's working. Now I want to expand that, right? So add more apps. I maybe add in a data warehouse on top of my operational database, and then I expand that again, right? Add a software as a service, add some microservices, and then maybe roll that out to another line of business where you've got a similar thing going on in parallel, or maybe it's an acquisition or something like this, and then you lift and shift some of that to the cloud, but not all of it, right? And before you know it, you have this sort of spaghetti infrastructure. This becomes really hard to query in a real-time, meaningful way. Like, getting the insights out of this mess faster is harder, right? Just because it's a mess, right? So not only can I not get insights out of it faster, I can also, it's harder for me to add new applications to this, right? Each incremental new application that I'm adding to this mess makes it messier. Right? And before you know it, people in your organization are going like this when you say, I need real-time analytics for my event streams as we go.
Yeah, so here is like, if you take a look at this slide, recall the previous one, we have an opportunity just to revisit this application stack with minimal impact on our applications. So there is nothing wrong with the applications, if to highlight this once again. But our streaming layer and storage layer needs to be reviewed. As for the even streaming processing, okay, Kafka is well known, right? Kafka, I think that is used everywhere. When it comes to the memory computation, and especially, right, as long as I'm representing GridGain is going to be reviewed for this architecture. But also, you can review some other possible frameworks and solutions. What's unique about GridGain here, those of you who attended my previous call with, my previous meeting, my previous talk with Gil 10 about Zool, etc., our GridGain goes with persistence, right? We still want to use some persistence layer. And we want to have less like spaghetti, right? We want to have fewer dependencies in our architecture. That's why for this use case also, we are considering that I want to process data right in RAM, but also I want to persist my data. If a cluster gets restarted, etc., we are going to use persistence. And the outcome of this simplification, when you took and revisited and hardened your architecture, is that you can get greater performance in memory, streamed, scalability to petabytes. You can scale out Kafka as well as GridGain. And this framework can be used not only for transactional workloads, also real-time analytics, probably some complex, it might be not ad hoc, but at least if you know that there are some predefined reports or complex queries, you can tune them and you can run them against this software stack. So how does GridGain fit Kafka ecosystem?
So this is an event streaming platform, right? I kind of don't like showing the slide because the cynical people in the audience goes, okay, another vendor putting their thing in the middle of everything. What's nice about Kafka as an event streaming platform is that it doesn't displace anything else, right? That spaghetti architecture that I was showing earlier, it's there because it works for a reason. There's nothing wrong with the applications, but by inserting Apache Kafka and Confluent Platform into the mix, and then one-off hooking it into this architecture, you can sort of enable your entire organization. You can enable your entire business. You can get applications talking to each other that have not talked to each other before easily. So we put GridGain on here as data stores. Right? The idea is we have a standardized connect framework by which you can connect different data stores to Apache Kafka and only learn the connect framework and not, for example, learn connecting to Hadoop, connecting to mainframes, connecting to GridGain, et cetera. But then they're first-class citizens along with your device logs, along with your applications, your microservices, and so on. And what we're trying to build here is this new notion of a contextual event-driven application. It's basically a new kind of application that's built as an amalgam of everything else in your organization. Kafka architecture, including GridGain and Kafka Connect. So what we're doing here is we've got a GridGain source, GridGain sync, and these are implementations of Kafka Connect. So in addition to Apache Kafka, we also include this thing called Kafka Connect. The idea here is to standardize connectivity, whether you're connecting to Oracle, whether you're connecting to GridGain, whether you're connecting to AWS S3, or any other data source, MongoDB, Snowflake, whatever it is, being able to configure that connection into Kafka without code, just on the command line using a standard Connect interface, really makes the value of the entire solution plausible. Right?
And here is, I think that even if you jump, little jump back for a minute. Here is I want all of us to pay attention to the configuration aspect of this Kafka Connect, what Jeff is trying to convey. The idea that even though you're a Java developer, you don't need to code all the times. And when we were preparing the demo that I'm about to show next, we decided that, hold on, yes, you can take standard Kafka, you can create and develop producers, etc. But how can we minimize that stuff? We already can go and use Kafka Connect. We can prepare some of the configuration files, etc., and deploy that Connect on their Kafka Confluent end. So we minimized kind of coding in favor of configuration. And for this demo, right here is to the, oops, wrong button. You see this pack of dollars. So for the demo, so how the demo works, we are going to start a Kafka source, simple application, that will read data from one service, and that service emulates stock market, stocks trading. We are going to read this information, we are going to push it into the Kafka Connect or Kafka, we are going to run some of the queries or the data, and after that the data will arrive to GridGain sync. And we will see how we can deal with that data next.
So it's the same queries on the GridGain sync and in Kafka.
Yeah, that's the point. So
right.
as we mentioned that for this demo we wanted just to use SQL. It's simple to use SQL, and a lot of people who are migrating from, let's say, relational vault or using relational vault together with Kafka, with GridGain, you can reuse your knowledge, your skills. You don't need to reinvent the wheel. Yes, there are some other APIs that are available that can boost the performance of certain operations, but SQL is a good start. So let's do the demo.
Sure.
Okay, and then you can switch back to the slides. So what we have, first of all, we have a terminal window. In that terminal window, I'm going to start a GridGain node. It can be Ignite, it can be GridGain, it doesn't matter here. But when it comes to the Kafka Connect integration, there is a special plugin available for GridGain users, so you need to use it with the GridGain cluster. So my first node is up and running. Let me make this demo a little bit more interesting and start another node. That will be 2 nodes cluster running on my local laptop. All right. Let's see. Yeah, I have 2 nodes on my laptop. So far, so good. What's next? Quickly, during the demo, we are going to use a management console of GridGain. I have a version of the console deployed locally on my machine. Let me just ensure that I still can connect to the just launched cluster. All right. Takes time by some reason. But finally, yeah, the tool made it. So I have these 2 nodes on my machine. Also, I created a couple of caches. The one will stores information about buyers, actual folks who are going to kind of buy all of those stocks that will be traded on the market. And here is we have a table with market orders, actually closed deals. All this information will flow from Kafka to GridGain. So there is nothing else started, except for Confluent platform that is already up and running, and our next step is to take and deploy GridGain sync that is already developed. We just need to do certain configuration changes, and then we are going to deploy our source connector.
Sure, so just we've got Confluent platform over here in the tab next to it. It's Control Center just showing it's empty, there's nothing in Kafka Connect, and there's no defined topics aside from a leftover query topic from before. So let's go ahead, and what I want to do is in configuration only, set up a data stream into GridGain via Kafka using this connector. Where's your system? So first thing we're going to do is deploy the connector. This is the GridGain sync connector. right? So this is basically, we have a properties file which defines how to configure this connector. I'm going to show this on the UI after it's deployed. Right, and we get some JSON back that just says that the deployment is correct. So let's go ahead and take a look. Let's refresh.
Do you need to refresh?
How do I refresh?
And this one. And
There it is. I'm not used to Safari. Okay, and then let's actually deploy the actual, let's get it started.
yeah, I think you need to deploy another one.
Yeah.
That was,
That loaded the connector, now we're actually going to run the connector. That's the sync. This is the market order source connector. There we go. This worked. Let's go back over here. There we go. So now we have this Connect running, populating a topic, right? So if I go over to my topics, there's my market order topic, and I can actually inspect that and see the data is flowing through there. Did we want to go ahead and get going on the queries as well?
yeah, let's do that.
All right, so let's say before the data even gets to GridGain, like GridGain's really good at fast queries over huge volumes of data. I want a real-time, timely query like as it's streaming through. So let's go ahead and use KSQL for that. So I'm going to go ahead and take this topic, and I'm going to define a table that defines this query. We didn't rename the stream, right? The messages are in Avro. The timestamp is timestamp. That's it, right?
Mm-hmm.
So we're going to just save that stream. And this is, right, so now if I actually take a look at this, where we can actually see data running through. Let's actually run an actual query on this stream. Here's a simpler.
Mm-hmm.
This guy is basically saying, oh, let's put it in and we'll talk through it. Right, so we're not just doing a basic select with a filter. We are doing a sum here. We're applying a tumbling window of 3 seconds, and then we're doing a filter, right? And then we're also doing a group by, and basically large orders over some value, the bid price over 200, and then an order quantity of bulk of groups size 10. The thing that makes KSQL a little different than traditional queries is that it's not just fire and forget. You don't just run it and get sort of this batch back. It's a persistent query that's always running. So this query is running on the stream as the events are going through, and it's updating periodically with this tumbling window. So I'm doing some pretty sophisticated aggregation and analysis on the data before it gets to GridGain. Right, and here you can see.
And here is like
The sample
well-known
data is actually
SQL. Nothing new, right? I mean that from the syntax standpoint, Kafka
Right.
SQL syntax will be pretty familiar for us.
So it looks like we're querying a database. We're actually doing stream processing. Here. Let's take a look at the next query just for fun. Right. We can stop this one. I can store this as a persistent query so that it's always running, or I can just run another one. Right.
All right.
Ooh,
Yeah.
Ethereum's doing well today.
Works. It works. All right, before we run the same queries on the GridGain end, let's quickly check how this market orders source looks like. So where are we taking the data from and how the Kafka topics
Thank you.
get populated.
Yeah, go
It's
ahead.
generally simple, generally speaking, that's my project. I'm a Java developer, but I didn't have a lot of, chance to code for this project because that GridGain thing was already developed, released, etc. We just installed it. We downloaded and installed it. As for the source, yes, here is, I've got that opportunity to code a little bit. So those are the tables that I created beforehand for the cluster. Why we didn't run this source code again after I restarted my nodes is because I have Ignite persistence enabled, and all of those tables, etc., metadata is stored and can be recovered upon restarts. But the source connector, that guy is more interesting. First of all, we need to increase the font size so that, guys, you can find out what's on the screen. No, that was the wrong one. We need to go here. Font. Right, like this way.
It's a little better.
Yeah,
Maybe like
should be much better. All right, so market orders, topic name. That's name of a PubNub service. If you know, that's a special service that is also used for streaming, and they publish some of the topics that generate, emulate market orders. You just subscribe to that topic, and we're reading all the data from there. Here is we're defining some of the parameters required for the Kafka, stream name property, etc. Configuration. Here is we are creating the topic, actual topic. Here is we're defining the schema name so that all the data that will be read from PubNub service, we are reading it, and for every record, here is, yeah, it's here. We are just reading every record, and we are creating a special structure. That's a Kafka API. And for every record, we just populating all of those fields, ID, buyer, symbol, order quantity, etc., etc. And after that, we just add this to Kafka. That's it. That's the whole source code we created for this demo. So that's how it's simple.
So what we're doing here is we're registering schema with a Confluent schema registry. Apache Kafka just publishes bytes. If you go into topics, I can actually inspect the topic that I'm querying here. I already built the table off of that in mine, so there was sort of inferred there when I was able to create a KSQL table off that. I can also see the schema that's included, and this is just JSON, name value pair is included, serialized in Avro, and that's also configurable. So schema configuration, loading data into Kafka, configuration only, and then standard serialization, standard connectivity so that we can query with SQL.
Yeah, and while we were kind of showing you this, the part of the demo for Kafka, let's see where the data ended up being. Because here is, if you go back to the grid gain console, we can see that the data keeps coming to the cluster. So it goes through Kafka topics. We can run queries over the Kafka, but also now the final destination, the final storage is grid gain. So let's go ahead and run the same identical queries. So the syntax here is for these queries, we can use the same syntax. It will be equal for Kafka and for grid gain. So I forgot to, I restarted grid gain web console for this demo, but I can find those queries easily. So that's the demo, GitHub, it's public, available.
Notes are great.
You just go back, create a notebook, SQL, okay. Let me run my first query. That's my query. Group by. I'm doing join, data. Okay, let's execute this query. Okay, there is some data, and I want to repeat this query, I don't know, every second. Let's run it every second. I want to see that the data is changing. You see that the data is coming. Now we are querying grid gain, and here is in real time. You can query your cluster. The difference is that grid gain will be storing not only real-time data but also historical one. It can keep it in RAM on disk. Depends on your requirements and depends for how long this whole solution is running. Right now it's like for how many? For 10 minutes. You've got it running for 10 minutes, but the data keeps coming and it's being stored in my small, tiny cluster on my local machine. Another query, right, the same query that we did for on the Kafka end. Let's do it with grid gain. You can run it in parallel, adding query. Symbols. Okay, so here's where we want to find the most popular stocks that are being purchased. Let's do it, and we see that Google, Apple, some line and cloth get interaction. So let's run it. And then the data also gets changed. So far, so good. So that's actually the whole demo. Let's quickly jump to the slides.
So we were able to query data in real time flowing through Apache Kafka, and that's not enough because then we can also contextually add the historical data that's in GridGain and get fast results with the real time data.
Yeah, and so right now let's talk a little bit more about the architecture. And that's your chance to give even more details about Kafka Connect.
So Kafka Connect, so when you're connecting a source to Kafka or a sink to Kafka, you would think it's not hard. There's a well-defined consumer and producer API for it. But how about if you want to do that in a uniform way, regardless of what your sources and sinks are? Kafka Connect handles a lot of sort of the messy infrastructure that developers tend not to worry about until they have to. And they usually have to do it when they're connecting to a real source and a real sink, and then they're having to handle a lot of these things in code. So there's a producer application, and there's a consumer application, traditionally with Kafka, and that we try to encapsulate within Connect, and we try to abstract away all the Kafka stuff. So that when you are a developer writing a connector, like if you're writing a connector with GridGain, you need to worry about GridGain. How do I connect to GridGain? And then what I'm doing in that connector is I'm populating a standard data structure, and the Connect framework is taking that data and producing it into Kafka for me. So I have my source connector, I have single message transforms, and I have converters for serialization. So my task here that's written on the left is the actual code that I write as a developer that knows how to connect out to my source. And then I have this configurable library of single message transforms, things like masking a row, renaming a column, things of that nature. So that if I'm writing out to a sink and I have a column name mismatch, or I have a column in my topic that's not present in the target, I can just drop that. So that's kind of a basic transformation operation that it's really nice to be able to do in configuration rather than code. With converters, it's serialization. What data is actually living on this Kafka topic? Is it Avro? Is it JSON? Is it byte arrays? Is it something else? How do I know that every consumer and producer writing to that Kafka topic is serializing in a standard enough way so that when I start reading from that topic, I get data that makes sense? Standardizing the in and out of Kafka Connect of Kafka from other data sources helps ensure that the data in the Kafka topic is usable regardless of what sources and sinks it comes from. One connector, there's the GridGain connector. I've actually verified this goal. I've been at Confluent for about a year. But it's one of an ecosystem of many connectors. We host these connectors on Confluent Hub, along with converters, single message transforms, and other sort of code libraries that you can use for communicating with Kafka. Licensing is included on here, so most of our connectors that are on Confluent Hub are Apache license version 2 or Apache v2 license, but not all of them. Some of them are proprietary. It depends on the vendor and the support restrictions and so on. And the idea here is to lower the bar on working with streaming data. So not just developers who use Java and Scala can process data using Kafka streams. We also want to lower the bar on that to anyone who knows SQL. Right? Core developers who don't use Java and Scala, data engineers, architects, DevOps, site reliability engineers. These are all kind of engineering types, but they're using SQL to process and query these streams in flight. And the door is open for BI analysts as we start talking to BI vendors and visualization tools that are generating SQL already, getting them to generate KSQL as well. So watch the space for that.
Yeah, so what happened on the storage end, on the GridGain side? So here is, the story is pretty simple. Two cluster nodes, right? On this picture we have more nodes in the cluster, and then we have client application connected. In this case, that's the web console, just the tool that works with our cluster. As for the Ignite streamers, how the data gets actually populated to GridGain. Yes, we created that GridGain sync connector that can be just downloaded and installed, but internally, at the level of the implementation, the connector uses Ignite data streaming API. That's the lowest level API available that a lot of the users use to load the data into a cluster initially, or to use for different real-time streaming use cases.
I don't want to interrupt, but I think that's an important point, is that you were able to use a low-level grid gain API for efficient movement of data against grid gain in a standard format like Kafka Connect. So oftentimes when you take an abstraction layer of Kafka Connect, there's a little bit of a trade-off between abstraction and performance. The goal behind Kafka Connect is not to have that, right? By enabling the developers who are writing connectors to code in the native interfaces of their
yeah, that's right. Otherwise, before we decided to support that Kafka Connect API and paradigm, usually developers, Ignite developers, Grid Gain developers, they would go and take Ignite data streamer and they would create a custom producer or like custom sync. It took time. SQL, right? Here is again, we are focused on SQL. For those of you who are not aware of Grid Gain, many more APIs are available, from transactions to key value, etc., just for the sake of the holistic understanding. And a little bit more information about Grid Gain distributed joins. For instance, those of you who attended Craig's session yesterday, he was showing how 24-hour Fitness uses SQL in production. He also perfectly well described how our distributed joins work. If you can allocate all the data properly, let's say you have market orders and buyers, like in this example, if all there are orders, completed orders, are stored on the same cluster node where I have a primary record of a buyer, then you can easily run collocated joins, avoiding any data shuffling over the network between those two nodes. And this slide just explains how this works. If we have a query like this one, where we are trying to find a number of cities in countries like Canada and India, we don't need to do a broadcast. There is no any data shuffle between two nodes, two server nodes. The query arrives to both nodes, all of those nodes running this query locally, and then our application gets a final, like two result sets, merges them, and returns to our application layer. And one last thing, actually that's it from the from the educational standpoint, but we still have our demo up and running, and we left it up and running for purpose. Let's try to emulate power loss, because this happens, right? But we are dealing with real-time streaming, with in-memory technologies. But if we go back to the demo, let me see how many records do we have in the cluster, because everything is still up and running.
This is scaring me a little. We didn't prepare for this.
Yeah, no, we didn't do that. And I think that my machine is already kind of is running out of resources, CPUs, memory, etc. But let's check. I already have 7.k like records in the cluster, and Kafka still keeps producing data. Let's now emulate this data loss. I'm going and just killing everything. Also, let me go ahead and abruptly stop all the grid gain nodes. So the cluster is gone. Let's say that was a power loss situation. No more data, nothing is getting in. And here as I can see that yes, we have disconnected from the cluster. Did I lose my data? We shouldn't. Because I enabled the persistence beforehand, and I hope that whenever I restart this cluster, I will be able to run the same queries over the data that is already there. So let me do this again. So now I am restarting my cluster nodes. I'm starting the first one and the second one. The order doesn't make sense. We just need to boot both nodes. All right. Let's wait. Okay, two nodes are up and running. What's about the data? Let's go back to the tool. Okay, it's auto-refreshed. I have the data. Two nodes are up and running. All right, and the records are here. So the data is not corrupted. The data is not lost. That's kind of, the usage of the best of both worlds. You can use in-memory as your storage for the sake of speed, but also the disk is there. It's consistent, durable, etc. And I am not preloading. I am not warming up my RAM. There is nothing in memory yet, so the memory is empty. All the data that is reported here is on disk. But I still don't need to preload anything. I will go ahead and just issue the same queries, and this time, as long as there is nothing in RAM, GridGain will automatically go to disk and will read all the data from there. Yes, queries will be slower, but at least we did not lose anything, right? And as long as you're running more queries, the whole memory space will be warmed up. Okay, let's execute this query. All right, that was the last snapshot. That was the last data set that was derived. I have some data. And here is the story the same. So restart, failed, power loss, whatever else, shutdown, production incident, you're not losing any data. And right now, again, we can restart Kafka, we can preload much more data in memory, and now the speed of the queries will be amazingly fast. All right, folks, I think that before we jump to the Q&A session, let me try to summarize. What's the purpose of this whole software stack? The digital transformation that is happening to the many businesses nowadays sets strict requirements for the infrastructure. You need to store 50 times or 100 times more data. You need to run 10 times or 100 times more queries. Classical, traditional legacy systems come short, they fail sometimes. You need to have a scalable solution. Now, when it comes to the scalable solutions, here we want to use the best technologies that exist nowadays. If you want to do real-time streaming, if you want to run and query data in real time with SQL, you can do that. Here we have Kafka. If you want your data to reside in some fast storage, which is scalable and distributed, that supports both RAM and disk, GridGain is one of the options. And SQL, again, for the sake of this presentation, SQL is easy to use. SQL is universal. So you don't need to learn a lot when you're doing your first steps with Kafka or with GridGain. You can just start using the tools you have used before.
Hope that made sense. Any questions?
All right, then.
Good.
Thanks for coming.